Okay, welcome to this video. Today we're going to look at how to make 3D models using data from Digimap, and today we're going to be using QGIS. There's a number of different data sets that we're going to use. These are shown on the screen at the moment. We'll go through these in a bit more detail as we work through the practical though. And as I mentioned, today we're going to use QGIS. So QGIS is the world-leading open source GIS software and can be downloaded for free from the URL shown there. And we're also going to be using a plugin called QGIS23JS, which again is a free bit of software, a free plugin that extends the functionality of QGIS. So without further ado, we're going to jump into QGIS, and we've got a blank project window open here. The first thing I'm going to do is change the coordinate reference system to use British National Grid, because the majority of the data we're using today is provided in British National Grid. So I'll just set that right, and then we're going to pull in some data. So the first data set we're going to pull in be a raster data set of OS terrain 5. So this is 5-meter terrain surface. It's provided in ASCII format, ASC here, and it's provided as tiles from Digimap. So we've got these two tiles here. We're going to add these to the data to the map window and close that. And if you can just make out, there's an area of elevation here, which is Arthur's Seat, and this is Edinburgh Castle. So first thing we're going to do is merge these two tiles together, just so we've got a single terrain layer. It just makes it a bit easier to deal with these things. So in the processing toolbox, we're going to search for a tool called merge. And under the GDAL area, we've got a raster miscellaneous merge tool. So these are raster data sets, so we're going to use the raster merge, not the vector merge tool, which is further up there. So we'll select our two DM layers. And this is actually a 64-bit data set, so we'll change that the data type to 64-bit. And we're going to save these to a file. So we'll put this in the terrain 5 data folder, and we're just going to call this OS terrain 5. It'll save it as a TIFF format. We just run it, it'll just add it to the map once it's finished. There we go. So now we've got a merged data set. We can get rid of the original two tiles from our project because we don't need these anymore. And you'll see, because the data now is merged, it's displaying a lot clearer, and we can make out individual features a lot more cleanly. So you can even see roads and some rivers and things like that. So this is Edinburgh Castle on the Mound, Royal Mile. This is Arthur's Seat area. Okay, so the next thing we're going to add on is some aerial imagery. So again, this is raster data. So we're going to browse to the folder where this was downloaded from. Again, this comes from Digimap, and it's provided in JPEG format. So you'll see we've got two .jpg files, which are both quite large. These are 1 kilometer tiles, so it's a smaller area than the terrain 5. But you'll see it slots nicely and falls directly on top of the feature that is visible as Edinburgh Castle Rock underneath there. So we've got two tiles now that make up our aerial imagery. And this is the area we're going to study today, because it's quite nice because we've got some trees, we've got buildings, and we've got an area of elevation right in the middle. So I'm just going to zoom in a bit more. So we've got a bit clearer view of the castle. Okay, and now what we'll do is we'll add on some more data. And then we can look at creating a 3D model. So if we go back and add in some vector data this time, we're going to add in some geology data. So in the geology folder, I've downloaded the 1 to 50,000 K geology data from the geology collection, and this is provided in shapefile format. You'll see there's 3 different shapefiles here. If we sort by type, sorry, there's more than 3. We've got 5 different shapefiles here. The one we're interested in today is the bedrock layer. So we're going to add this to our project. Now you'll see we've got various features drawn in here. Yeah, okay, so the geology data provides information here on the bedrock that we've got across the area, and it comes in categorized. So the British Geological Survey have categorized the data, so we can choose to display this information using the category, and we're going to use the LEX RCS attribute value, which is rock classification scheme. We can do random colors, and then we'll just press the classify option here and hit OK. And now you'll see we get a much more colorful map, and each of these features is a different type of bedrock. So if we select if we select this feature here, for example, you can see on the right hand side, this is an igneous feature made of igneous rock, so that's volcanic rock. If we choose this larger sort of pinky orangey color here, you'll see this is a sandstone sedimentary rock, so this is much softer. So that's some of the information that's available in the data. Let's just close this pane. Okay, so there's our geology data. Now what we're going to do is we're going to turn off the geology data, and we're going to turn off the terrain 5 data, and we're going to zoom in on Edinburgh Castle and the castle area here. And what we'll do is create a 3D scene of this particular area. Now to do that, we're going to use the QGIS to 3 plugin, which once installed lives under the web menu. And you'll see we've got here QGIS to 3JS. So we'll choose that. It opens up another window, which I'm just going to expand. And this is where we'll build up our 3D scene. So the first thing we're going to do is choose what is our terrain layer. So it's detected that we've got a digital elevation model loaded for OS Terrain 5. So we can enable that. If you wanted to use a flat plane, you could do that. If you weren't bothered about the elevation, the actual ground elevation, you could choose a flat plane. Or if you didn't have access to a terrain data set. So now you see we've got a nice 3D model already. It's draped the aerial imagery over the top, and we can navigate around this and see the actual terrain in the area. It's very nice. What we can do to this is show how tall the area is by double clicking on it, going to the properties of it, going to others, and then selecting the option to build the sides and add some edge lines. And what this will do is it'll build up effectively like a 3D model from sea level. So if we hit OK, so now the bottom of our sort of slab is sea level, so it's 0 meters. And we can see how high the area is, which is quite nice. Now to view our geology data on top, we need to enable it in the panel on the left hand side here. And you'll see it's actually drawn it underneath our model. Now to get it on top, we double click on it to see the properties, and we start changing some of these settings. So first thing we'll do is set it to be an overlay, and we'll say that it's relative to the terrain 5 layer. And if we just tick the export attributes and hit the OK button, you'll see it draws now on top. But because it's drawing the geology data exactly on the surface, you see we get these sort of weird data artifacts where you can kind of see through it. So what we can do is just offset that ever so slightly by 1 meter. So if we set the altitude so it's 1 meter, it effectively means in the visualization the geology data is hovering 1 meter above the ground. But for this purposes, it's very close. You can see the gap at the edge there. Now you can see the geology of the area and how that's affected the topography. So this is obviously a different type of feature. And if we click on it, you'll see this is the igneous, so the volcanic plug. And then this sort of reddy area around about is the sedimentary sandstone, which is a lot lower, lot softer, and has been eroded a lot more. And this igneous plug has remained, which is what the castle's located on. So that's quite a nice, simple 3D visualization using 3 data sets. We've got our terrain 5 that's making up the elevation. We've got the aerial imagery, which is drawn on top to give us a nice 3D visualization, and then we can drape the overlay, the Geology 50K bedrock data on top of that. Now, there are other data sets we can use to build a more realistic 3D scene. If I turn off this bedrock layer, we can just close this and go back to our map window, and we can add in some of the other data sets. So the next one I'm going to add in is a vector data set of building height attribute data, which comes from the Ordnance Survey collection. It's provided in open file geodatabase format or Esri file geodatabase format. So we choose directory and of type file geodatabase. We'll go to the folder where this was downloaded. And we've got two geodatabases, so we need to select them individually. And I'm just going to add these in as two separate layers. I'll add in the second one. Add this. Okay, so you see in our area of interest where we've got data, it actually falls directly down a tile boundary that this data is provided as tiles. So what I'm going to do is I'm going to clip out this section in the middle just so we've got the data that we need and not too much, otherwise it can slow the processing down. You can create 3D models of big areas, just be aware that it'll be a lot slower to generate and to render. So in order to do this, first thing we're going to do is merge these two together into a single data set, and then we'll clip out the bit in the middle. So back in the processing toolbox, the merge tool we want to use this time is under Vector General, Merge Vector Layers. So we'll choose our two building height attribute data sets. We'll set it to be British National Grid because that's what the data is, and we'll save these to a GeoPackage. So put this in our building height folder, and we're just going to call it building height attribute. And we'll run this. So it won't take very long because it's just two data sets. And you'll see once it's finished, we've now got a single data set, which is all the buildings across the area. So we can remove the original two tiles that we downloaded. And now this one, we just want to select out the bit in the middle. So we can choose the select tool. We can draw a big polygon to select those features. We can then invert this selection because, and then these features we can just delete them. So we'll click the edit button and then the delete button. And then we'll stop editing and we'll save our changes. So now our data set, we've merged the two tiles together, we've just saved out the bit from the middle. So now if we go back to our 3D model, I'll just zoom in on the central area of the castle again. Okay, now we can go back to our plugin. So QGIS to 3. Now it's remembered the settings for our OS terrain layer. And our geology layer will still draw on top if we want to use that as well. But for this one, what we'll do is we'll keep the geology off and we'll turn the building heights on. So building height attribute data, again, it's displaying underneath the model at the moment. So just like before, if we double click on it to bring up the properties. Now, if we leave it as a polygon, we can set it relative to the terrain surface so that it appears on the top. And just like the geology data, if we offset it by a meter, you'll see we get the buildings on top. Now, the good thing about the OS Terrain 5, the building height attribute data from Ordnance Survey, is that it comes with a number of different building height attributes. So we've got some absolute values of the minimum height, the absolute height 2, and the absolute height maximum. So height 2 is around the eaves area. The maximum is the apex of the roof or the chimney pots, whatever they are. And from these three absolute values, they derive two relative values. So we've got rel H max, which is the relative maximum height of the feature. And we've got rel H2, which is up to this eaves level. So we can use this information that's stored in the data to extrude our features in our 3D model to show them in 3D. So to do that, bring up the properties. And we say, instead of being type polygon, it's type extruded. Relative to the OS terrain 5 layer, we'll set that to 0 so it's sat directly on the layer. And the height of the features, we can choose either of these relative heights. So if we choose rel H max, that'll extrude the features right up to the very highest point. So now you see we've got a very nice 3D, very simple 3D representation showing the buildings in the area that we can pan and zoom and navigate around and see how the landscape sort of really does actually look, which is very nice. So each one of these features, you can see if we click on it, we've got these absolute height values and these relative height values. So this feature's been drawn rel H2, which is 22 meters above the surface, so it's been extruded 22 meters. So that's the building height attribute data that's provided by Ordnance Survey. Another 3D model, another 3D data set that's available is provided by Verisk, which is an interesting data set because it actually includes information on the age of buildings as well. So if we browse, it's a vector data set. And if we go to the Verisk area, this is a data set called UK buildings. And it's basically a separate set of building polygons that are available and have different information on them. And if we select one of these features, you'll see it's got some information. One feature, one attribute value is the age. So this feature was built in the 60s, 70s. And it's also got a use column as well. So in this case, it was a community or governmental building. Now, so we can color these buildings using that age value simply by going to the symbology tab, choosing categorized and choosing the age attribute. For these, we're going to use a color ramp. So let's do spectral, and I'm just going to flip this color ramp. So I'm going to invert it so that older features are shown in a darker color. Here we go, and newer features are shown in a redder color. So unclassified buildings will come in a sort of orangey reddy color. Older buildings will show up in a bluey color. So if we OK this, you can zoom out a little bit. You can see there's a whole range of building ages in this area. We've got some modern buildings showing up as these orange features, reddy orange features. Here's the train station. This is the 60s, 70s building. These ones here in this sandstone color are a modern feature, and then we've got blue ones here which are historic. So there's a whole range of features in this area, but it's quite a nice data set because it shows this information. So we can use this now, and we can, oh, I should say as well, each of these features does have a height, so they do have a height attribute as well. So we can extrude the features up to that height value. Oops. Now, if I just zoom in on the area, there we go. Now we'll go back to we'll turn that layer off, and then we'll just extrude it in 3D using the plugin. Okay, so this time we want to enable the UK buildings dataset. Just like before, we'll open up the properties, choose extruded, set relative to the terrain 5 layer. Altitude is 0, so it's drawn on the ground, and the height, well, we'll choose the height attribute. We'll keep the color style as the feature style, so that's what we've set in our main map window. We'll choose to export the attributes so we can access them in here, and then we hit OK. And there you go, we've now got our nice 3D scene, and we can see the areas where there's older buildings and newer buildings and the effects these have on the landscape, which is quite nice. Choosing one of these features will bring up the pop-ups so we can see the attributes for each feature. So this is the 60s, 70s building, and there's its height. So that's quite a nice visualization. Again, we've just shown using two different building height data sets, one from the Ordnance Survey collection, which doesn't have age information, but the one from the Verisk collection, the UK's buildings data set, does have age information, and we can color that data accordingly. Now, the final thing we're going to do to this 3D scene is add in some tree data, which comes from the National Tree Map. So I'll turn those buildings off and just close the plugin window, and we're going to add in some more data. So vector data again. So this is the National Tree Map data. It comes from the Ordnance Survey collection. That's how you access it. It's provided in GeoPackage format. And when we add this, there are 3 data sets in this, so we'll just select them all and let's add them to a group. And we'll add these and we'll close this and we'll just explore what they look like. So the first one to mention is we've got point data. So each tree is provided as a point and it's got a number of attributes to it. So it's got a maximum height, mean height, an area, and a perimeter. There's also some other information around dates captured and things like that. So that's the point data set. We've also got a data set of crowns. So these are stylized crowns. They've been stylized as circles. Gives a nice overall impression of the tree cover of the area. But there is also a third data set, which is the canopy data set. So this is where they've tried to accurately delineate the canopy for each tree. So if we put the points on top, so you can see where the main trunk of the tree is, and you can see where the canopy of each tree is. Compare that with the crown data, which just shows sort of generalized, stylized crowns. So they're the 3 data sets that come from the National Tree Map. What we'll do is we'll turn these all off, and we'll go back to our 3D view. Let's just zoom out a little bit. And we'll build a 3D view of this area still. So go back to the plugin. There we go. So again, it'll have remembered our buildings data sets and how we stylize those. We'll just turn those off for now. And what we'll do is we'll start building up some trees. Now I've enabled the points, so these are the tree point features. And as you can see, these are drawn underneath our map as before. They've come in as spheres. What we'll do with these tree points is use these to make trunks. So rather than being a sphere, we'll change this to cylinder. We'll set them to be relative to the ground surface. Their radius, to make these proportional to the size of the tree, we'll take the max height value and we're going to divide it by 40 because that provides quite a nice sized tree trunk compared to the height of the tree. And the height we'll set to be the maximum height of the tree. If we save that, you'll see our trees come in. I've just set the feature style, the color to be the feature style, so they're all drawing as a sort of pink color. You can override this in here and you can choose your own color. So if we set this to expression, and then we'll choose a nice browny color. There we go. So that's a fairly good dark brown color for our tree trunks. So you get an impression of where the trees are now around this area and how they appear and how the relative heights of each of them are. Okay, so what we're going to do now is put our crown data on top. So crowns are the stylized crowns that show a circle now again. As we turn them on, they're drawn underneath our scene. So we'll just choose to put these on top. So these are going to be drawn as an extruded feature. Now the mode of these relative to the terrain surface and the altitude of these, we're going to set these to be the maximum height of the feature, but we'll divide that by 2. So the crown is drawn sort of halfway up the tree trunk. And for the height, again, we'll set this to be the maximum height divided by 2, so that they're drawn halfway up the tree trunk and they occupy half the height of the tree. The feature style will set to be a sort of greeny tree color. So if we just choose green, and we're going to set the opacity to be 50% to represent how you can see through trees, through the branches of trees. Now if we just hit OK, we'll see we get some features drawing. Now if we zoom in to an area just so we can see some of these trees in a bit more detail. So now you'll see we've got our trees, they're drawn at the maximum height of the data set, and we've got our tree crowns drawn halfway up, halfway up the trunk effectively, and occupying that sort of top half of the feature. So what we could do, we could actually shorten our tree trunks and maybe stop them 3/4 of the way up. So this is our point feature data set here. And we can simply do that by saying the height of these features is maximum height multiplied by 0.75 to represent 3/4 of the height. And now you'll see we've got a much better realistic looking tree. That's the maximum height of the feature is correct. We've got tree trunks 75% of the height. And if we zoom around to the other side, Edinburgh Castle, there's a lot more trees in this area of parkland around the other side here. So that's looking pretty good. So now we can turn back on our UK buildings data set so we can see how the landscape looks. And now all the modeling we've done so far is just taking place in this plugin window. Now with this plugin, we have the option to export this to an external file. So at the moment, it just lives in our QGIS project. If you wanted to share this with somebody or publish this visualization so that others can interact with it, we can do the file export to web option. And in here, it'll jump it into a temporary directory, but you can obviously browse to a directory if you wish, and it'll call the file name index.html by default. The thing that we want to enable here to do before we export it is to select the option to enable the viewer to run locally. And just this means that it'll be able to run in web browsers. So we won't change anything else, and we'll just press the export button. You can export from this plugin as many times as you wish. Once you've got your visualization set up, you can practice exporting it and seeing how it interacts once it's exported. Now here we go, we've got our index file. This is an HTML file, and it's at this particular location. So this will be the location on my file system. So if I paste that into there, these are all the files that make up this 3D visualization. So if you want to share this with a colleague, you would need to share the whole folder that makes this up. So this is the file that we're looking at, the index file. But all these files and folders make up the 3D scene. And now we can interact with it in a web browser. So most modern web browsers will support this, so Chrome, Firefox, Internet Explorer, Edge. And depending on the settings that we had enabled, so here you can click on the features and see the information. So this is our 60s, 70s building. This is a historic building, different height. Don't think I enabled the attributes on the trees, but you can enable that in the settings. It's just the export attributes option. So that's quite nice. Within this 3D scene, there is a menu here shown with this little layers icon. Even though we set our opacity on our crowns to be 50%, you can modify this once you're in here. So if you want to make them more opaque, so they are less see-through, as you might get in summer months, or less opaque as you might get in winter months, you can dim the opacity and modify the opacity. Similarly, you can interact with layers in here. You can turn layers on and off. So if you're no longer interested in the trees, you could turn the features off. So remember, we've got trunks and crowns, or you could turn the buildings layer off. And there we have it. So there's a very simple 3D visualization using a number of different data sets, all downloaded from Digimap, all created in QGIS, using QGIS and the QGIS to 3JS plugin. I hope that's been useful, and we'll do some more videos in the coming weeks where we look at doing the same sort of thing in different packages. Thanks very much.